Swayam Prabha. Digital India. Educated India.
Alright, today we'll learn a new technique for the apportionment of the sources. It's often a matter of interest to know where is the pollution coming from. Okay, you might be staying at one location and in a residential area, and you like to know how much is the contribution from the petrol vehicles, how much is the contribution of diesel vehicles, how much is the contribution of, let's say, there's a power plant close by. So you would like to know about these sources, and once you know about these sources, you can certainly control those sources. So there are many techniques as to find out the contribution of various air polluting sources to the ambient air which people breathe, and this contribution of these sources will be variable depending on what location the person is or what locations the measurements are being done. So one of the technique is called receptor source modeling, and it can be used for the particulate matters. It can also be used for the organic pollutants to clearly say what are the sources and how much is their contribution. So if we move to the first slide, in the terms of what you are seeing here in the circle in the middle, suppose you are doing some measurement. Okay, so this is what is the instrument that measures the particulate pollution. Okay, and this instrument is measuring, and we want to say how much is the contribution, let's say, from the cars at this location, how much is contribution from, let's say this is refinery, for example, let's say this is some power plant, and say that this is some iron steel industry. Iron and steel industry. Okay, and what ideally we want to know, and if we can, is to apportioning of the contribution to the monitoring ambient air levels of pollutants among various sources. So this is just a picture which we want to understand at the place where I am doing the measurements, what are the contribution of the various sources. And once I know which source is contributing and how much it is contributing, is up to me to decide the pollution control strategies and to prepare the pollution control plan. But how to accomplish this? How to kind of know that what is the contribution from the various sources? So this technique we'll learn. One of the techniques you already know, that is using the dispersion modeling. But here we'll talk about a little different kind of modeling. So the basic requirements to assess the air pollution sources and receptor relationship. We want to know the linkage between the receptor and the source. And what is the receptor? Receptor is a place where we are doing the measurements, or place of the interest where we want to maintain certain levels of air quality. Receptor can be residential colony, it can be the people, it can be, let's say, ecological park where you want to control the air quality for a particular reason. It can be very important buildings like Taj Mahal that you want to control certain air quality there. But in order to control, in order to plan, in order to prevent the pollution, you want to know how much is the pollution that is coming from different sources. So So essentially what we are looking at is to develop and understand the linkage between the source and the receptor impacts. So what as you see on your slide now, we want to understand the chemical and physical characteristics of the air pollutants, okay, understand the transport from source to receptor, how it is transporting, and finally estimate the contribution of each source of air pollution concentration measured at the receptor. Okay, if we can answer the key question, that is, again I repeat, contribution of each source to air pollution concentration where measured at the receptor. If I know this, I think I got very good information and I can plan and design my air pollution control systems. So okay, let's see. To further elaborate on what I said, suppose you know the sources and you know the source contribution to the ambient air quality, and then it can immensely help the pollution control planning. This is what is ideally you like to know. For example, ambient air concentration was 100 microgram per meter cube at a particular location where you did the measurements, and if you can clearly say out of this 100 how much came from cement plant, suppose, and that was in your vicinity, how much came from the power plant, okay, how much came from diesel engines, and how much came from steel plant, let's say. Okay, this is a very good information if we can get such information. Obviously one can quickly say that if I want to maintain a better quality than 100 micrograms, then if I control the sources from the power plant, okay, that will significantly improve my air quality. Okay, but you can also come to know you can even optimize your source control. Okay, you can tag a cost function for the pollution control at the cement industry, for the power plant, for the diesel engine and steel plant, and optimize that cost function so that you will improve the air quality at the minimum cost. But the question remains as to this nice looking picture with source contribution clearly specified, how to obtain such figures. That is what we are objectively will try to answer this question in this lecture. Okay, the idea here is once we know, then we can back calculate the impacts due to specific sources. Okay, again similar thing, if you are doing the measurement, let's say at various locations. So this is site 1, let's say, this is 2, this is 3, and this is 4. Okay, and you also may be knowing your source in the area 1 or 2, but there may be a source which is not known to you. So what happens when we are doing the measurements? All source in some form contribute. So essentially we like to know sometimes and how much is the contribution of these sources at the locations where I am doing the measurements, as well as I like to know if there is any unknown source which I have no information about. So you can also, at least up to a certain degree of confidence, you can find out with the help of the receptor modeling that we are going to discuss, even for the missing or unknown sources, and we'll see how this is done. Okay, the basic data requirement, what we need to have in order for us to do such a modeling exercise. If we know this information, as you can see here, all of them or some of them could be very useful, and what we call that one speciation. It means the particles which we have sampled, what are the different components of the particle, what is inside the particle in terms of its chemical composition or particle size distribution, because this might be very good information, because suppose you have most of the particles you are getting very fine, okay, and then you also know the soil that contributes the particle which are larger in the size. So if most of the particles here are getting smaller, it means you can almost be certain that, well, this pollution is largely not from soil, but it is from somewhere else. And in your area, suppose you have lots of diesel vehicles, then diesel vehicles will contribute very fine particles, and then based simply on the particle size distribution, one can, if not fully, but to a certain extent, can say what are those sources that are contributing. If you have additional information in terms of the elemental composition of particulate matter, that also is to the great advantage. Okay, but we will see how this will become to our advantage as we proceed, but this information is required, and also other inorganic information of the speciation. For example, what are the nitrate contents, what are the sulfate contents, okay, in addition to the elements like heavy metals and all, but you also need to have the information on the inorganics like sulfate, nitrate. That will be very helpful. And even the organic components, whether they are the aromatic hydrocarbons are there, and within the aromatic hydrocarbon, what are the different species of the hydrocarbon that is present in the atmosphere, in the particle. So in order for us to be able to do the receptor modeling, we just don't need the concentration, okay, but we also need plus speciation of the particles. In what form? Possibly size distribution, elemental composition, additional inorganic and organic composition. If you have these additional information, then we might be able to say, of course we have to learn as to how we can say that, is to what will be the contribution of various sources. And finally, what we want to look at the end of the day is some picture which looks something like this. This is the information we need to collect from the site and utilize this information for our source contribution or source apportionment. So if more and more information is available, that's all the more better, as you can see here. Okay. Now before we move to the receptor model, you also would recall that we had done some modeling exercise with the very same purpose to find out the impact or contribution of the various sources in the ambient air, or in other words, to develop the linkages between source and receptor. What we did was we studied something called dispersion modeling. Okay, you would also remember that we did something called Gaussian plume model. That model we applied to the large sources. That model we also applied to the vehicular pollutions or the area sources. So quickly we will take the recap of dispersion modeling and compare it with a new technique that we are going to learn, that is a receptor modeling. So there are two things, dispersion modeling and the receptor modeling. Or dispersion modeling is also sometimes known as the source model. Okay, so what you do that we have learned is we have the known sources and their emissions quantity. Then you need to know the dispersion parameters, and if you recall, for example, what were the dispersion parameters? Wind speed, okay, wind direction, okay. If you recall, we also had discussed stability, atmospheric stability, okay. These were some of the common things that we needed, and we developed that model. And then what that model eventually did, we started from the source and went all the way to the receptor. So our direction of the movement, as you see the arrow here, is from source to receptor. Okay. In the receptor modeling, it's just reversed. Our whole idea is to go from the receptor to the source and to say which sources have contributed to air quality. So here such models are called, where we are having some measurements already done and then trying to say what are the sources, those contributed at the site. That kind of thing we call as a receptor model, and the dispersion modeling was just reverse of that. So in order for us to be able to do the receptor modeling, what we need is some sources which are already existing in the area. sources means the emission sources. But the interesting part is we don't need the quantity of the emissions from the sources. Okay, we don't need how much tons of sulfur dioxide is emitted from the source. What we need is the characteristics in terms of the fraction of emissions. We say, oh, all right, the particulate matter emitted from such and such source, the calcium fraction is 20%. That is all the information I need, rather than having to know that calcium emission is, let's say, 1 ton per day. So that information I don't need. I need the information that within the source, what are the fraction of the various species that are present. Then we also need to know the measurements which we have done on the field, known ambient concentration. So this is essentially referring to this measurements here. And if you know some dispersion parameters, it is not a compulsory thing, but then you can also kind of do the interpretation in more better way. So henceforth the focus will be on receptor modeling, which will be something from here to here. But before we talk about the receptor modeling sounds very good thing, because it does not require many of the information that we needed in order for us to be able to use the Gaussian kind of model or dispersion kind of model, but then it also has its own limitation. Okay, what are the limitations of the receptor model? Cannot replace the dispersion model or the Gauss, something like, you remember we had something called the Gaussian model. So it cannot replace those models under certain situations. When you want to do the future predictions, suppose you want to, in your area, new refinery is about to come, receptor model cannot help you. No contribution from the proposed installation, that's proposed or new installations we cannot do, nor we can say what will the future thing will look like. Simulation for the change in the stack and flue gas parameters cannot be done. Suppose in the simulation I just want to say, okay, my chimney or stack height is increased, let's say from 100 to 200, what impact it would have, what will be the benefits that will accrue out of such a change in the stack height. That receptor model cannot say. That only one can learn from the dispersion model. Stack height determination cannot be done, okay, and the source contribution to formation of secondary particles. Okay, if you recall, secondary particles are particles which are formed in the atmosphere, such as sulfates and nitrates. So suppose the interesting part is secondary particles, there will be a gaseous pollutant, it might react with another gaseous pollutant, and what you can may get is the particles. If such a reaction or such a mechanism is happening, receptor model would not be able to tell you with great confidence as to who is contributing to the formation of the particles which are secondary in nature. That's right here, secondary in nature. So it is not it's not that receptor model can answer everything. There are certain things which receptor model cannot answer. Nonetheless, receptor modeling is very powerful tool and very useful tool. So this slides quickly show you the difference between the dispersion model and receptor model. Okay, dispersion model will go rather quickly. The prediction of the future air quality is possible. Okay, and we'll probably go this way. Okay, and see that analysis of the alternative control strategies is possible. Identification of secondary aerosols is possible by employing the atmospheric chemistry. Impact of the prediction with change in stack height and the flue gas parameter can be done. Identification from single group source within the similar characteristics can be done. Whereas the receptor model, physical impacts can very well be considered, because we don't even know the physical location, we don't even need to know the physical location of the source where it exists. We can still tell. Okay, analysis of the actual and worst case impacts